the discussion on the Chapman-Kolmogorov equations in lecture in the tutorial yesterday, and then we saw the and we discussed. We stopped here. The probability. I mean, that's why the notes I sent to all of you. The reason is you will come prepared. What happened already, and the next two slides, which will finish the. So we stopped here. The probability of A1 intersection A2 intersection EI. So we multiply and divide by the probability of A2 intersection EI. So this entire thing will become summation of probability A1 given, because if you see this part, A1 intersection A2 intersection EI, then if you treat A2 intersection EI together, this is A1, this piece, A1 intersection this particular set together. That means A given A intersection B means probability A given B multiply probability of that. So that's why this is nothing but A given B, that part is there, probability A2 given A2 multiplied by EI. So you apply again for that. Twice you apply. So at the first stage, you apply probability of this piece together. So that becomes probability of A1 intersection this piece A2 given EI. So I will erase that step I skip. That becomes probability of A1 intersection A1 given A2 intersection EI. Then probability of multiply that by probability of A2 intersection EI. A given B, and then probability of B, this part. Now again, probability of A2 given EI, it means again you can write probability A2 intersection EI can be written as probability A2 given EI multiplied by probability of EI. So instead of that, here, just a small trick here, algebraic trick, instead of considering A2 intersection EI, I consider EI intersection A2. So that becomes this thing multiplied by probability of EI intersection A intersection A2. That means again A given A intersection B, probability of EI given A2 multiplied by probability of A2. So all combined together, it will become probability of A1 given A2 given EI multiplied by probability of EI A2, because the two gets there. These terms are there readily. So again, this means EI intersection A2, EI intersection A2 given probability of A2 by probability of A2. That is there, this piece. So applying that, we can apply the same property here, because the K is changing. You see, K for all, as I explained yesterday, for the various things, K is an arbitrary. So I to J through K. K could be any of the states. So that's why we need to sum up over all the states. That's why K belongs to S, summing of all the states. And then this probability I to K, K to J, and then I to K. That's what probability of I to K. The same thing in the theorem, the result in the previous slide. So applying that, we get the summation. This is equal. So please, all of you, during the course or after the course, please verify yourself the derivation of the Chapman-Kolmogorov equation that is explained here. You have the slides. Now that would actually, understanding that, you put pen and paper and see what is I, what is K, what is happening there. So as I explained, you repeat that and verify yourself. That's very important. And then you would really go to the next level of your intuition on what's happening in the stochastic process. So that actually results to PIK, ML, PKG, LN. And each and every step is already given in the slides. So that ends the Chapman-Kolmogorov. And then the PIJ n to n plus 1 is usually one step. We just write it a PIJ. PIJ means it's a one step. More than one step, we write in the bracket there. So time only changes. That's what we mentioned. Probability does not change. The Markov chain or the time So the change in what is happening is, Pij, the probability of transition is changing. I mean, the time from one step to other step. And the value, whatever value compute, that remains the same, because I to j, we already saw that, the how do we, just notation sake, I'm writing p n comma n plus 1. That ends the Chapman-Kolmogorov. And then I have actually, the project also designed for you. This also I'm going to share as a end of the day. The idea is here, I want you to, all of you, yesterday someone asked a question about the hospital. The two questions raised actually. Several questions raised. I want to address this one question on the project. Someone how to do a project. So this slide I'm going to share with all of you. So this is a project after the GAN program. You all can try. Nearest go. So first step is go to a hospital. Nearest. This is the basic thing you need to do. And then out of the total data from a hospital, in the hospital which handle the COVID data, classify the patients who are tested positive for COVID-19 and not having any comorbid condition. Comorbid conditions here, you can take as many as you want, but essentially take heart, hypertension, and diabetes. Three things you take it, or maybe you can add fourth thing like smoking. So these four type of patients have shown severe conditions before vaccinations. So you can take all the 3 or 4 according to your own data availability. And then again, second step, classify the patients who are having, first step is not having comorbid conditions, second having comorbid conditions. Third step, patients are not having comorbid conditions and recovered. Patients having comorbid conditions recovered. Step 5, collect the data on number of patients not having comorbid and died, not having comorbid and died, all the categories. And then study the transitions. What the transition, you form a transition matrix, and then obtain the you see the Markov chain, how you fit a Markov chain for that data, that kind of data. Just a project. This slide will be shared with all of you anyway. The project. And the other thing, the yesterday, that part I think I need to write here a little bit. Let me create a new slide. So one question also asked, I thought I did not, perhaps not able to convince the questionnaire, those who asked. So there was a question where, when we are computing P and T in the counting process, the two conditions were considered. One is the probability that there are n minus 1 at T, and then within a small interval, one event occurs. One event plus R. This R, that means plus probability that there are n events up to time T, and during a small interval, this is like an interval within a H, delta H, and then 0 events. So the question was, why do we don't have to have a order of H here? Yeah, some books do mention order of H here, but it is not needed necessary, because if you mention order of H inside that, because only two possibilities are there. According to the condition, counting process condition, only two options. There cannot be any other option of having more than. So more than one event is ignored. So this here, not considering the order of H outside also still fine. Because if we are adding order of H inside this 0 events or inside a 1 event component. That's I want to clarify. Let's continue now with the further. So yeah, more. So I have more examples here on the. So this example is taken by taken on from the actuarial sciences. This thing, materials, their own Institute of Actuaries. So idea is, Markov chain, an example of the Markov chain. Motor insurances or health insurances. Motor insurance, car insurance. In general, it is given on it is every year we buy the insurance, and these companies charge the premiums based on our history of accidents. So the customers are given no discount. Three kind of customers, real data. Customers are given no discount, or customers three kind of the customer data. Customers are no customer 50% discount. So the states, different state. This is how they don't tell you the motor insurance or health insurance or any data. Health insurance means there is no year to year there is no discount because there is no management. There is no way to measure the how we are maintaining the health. But in case if it is a car insurance or a bike insurance, then they can know whether how well you are driving. If there are any accidents in a year, that means you're not a good driver. And there is no accident, good driver. So good drivers means they get some discount in the next year. That's how the so a claim free year means any individual claim free in the current year. Next year they go to the higher, better state of more discount year. More next year, more discount. So that this is the kind of data. And zero and further as the stochastic modeler, the idea is to classify the data accordingly. So zero means state zero no discount, state one 25% discount, state two 50% discount, and so on. No discount, 25% discount, 50% discount. So XN, now we are this kind of data. We are not generating any numbers. What we are generating is understanding the probability of change in the states. So what we let XN be now, since already last 2 days you heard the formulation of the states and the state space. Directly now you can connect well with the XN. XN is a random variable describing the status of a person in terms of the discount in the year N. So XN, the time here, N is a time factor, here the time is a year. XN means random variable describing the status of a person. What is the real English state, not state? State in terms of the discount. What is currently how many people who are in motor insurance, they are in the what state? So the state that means that's a status. So then unless these rules discount, the discount of policy changes, unless there is another new policy comes within the year, based on the information given, there are only three states in a state space: 0, 1, 2. So 0 means no discount, 1 means 25% discount in the next year, 2 means 50% discount. So the probability of the claim is 3/4. Claim free year means 3/4 means the probability is given to us, probability of transition. That means each year you see state 0, state 1, state 2, 0 to 3/4. So remaining balance is 1/4 to come back. Probability to go to the better state, that means 0, no discount to 25% discount, 3/4. Again, this year, no accident, they go to the next state. There is no further discount beyond 50. That's the data, you can have as many discounts as you want for the sake of mathematics. But then for the simplicity, 0 to 1 and 1 to 2. And then 2 to 1 with the probability 1/4, 1 to 0 probability 1/4. To somebody with no discount remain in the same state is 1/4. Somebody in 50% discount remaining in the 50% discount is 3/4. This is how this kind of probabilities I want you to build on the COVID data based on the project that I provided. And each of you can write your own, collaborate with a local hospital, and then write an article. Similarly, here this data, this is called transition graph.
Sir?
Sorry, go ahead, ma'am.
Sir, is it possible to go from state 0 to state 2 directly?
According to the assumptions, according to the given information, no. Because each year 25% discount based on the current year. If there are that means no accident in this year, so next year the policy premium we pay only 25% discount of the current year's price. Whatever, if you 1,000 rupees we pay only 750 next year.
Okay.
Sir.
Yeah.
If I may ask, related this example that you have given just now, just comparing it with the HIV example. Similarly, there you have described 4 states. First is that HIV status, and then they get the infection, then AIDS, and so on. So there, from state 0, they can jump to state 2 directly. HIV status to AIDS directly, or
Correct. Yes, they can jump. That's that under that situation. You are right.
right. Okay. So that means we have not diagnosed it in between because he actually has to pass through the state. But when we were counting it at that point of time, the transition is directly from HIV status to AIDS without intermediate stages.
Yeah, because the intermediate stage is STI. So one may not get STI. One may directly get HIV from a susceptible, can directly get HIV, or susceptible directly get STI. Or susceptible can get a STI first and then from STI to HIV.
You're right, sir.
So it
Right.
is situational. That's what, as I mentioned in the other talk, I like it, I do it, it will not hold here. What is practically happening, we need to build a model for that. So in that situation, you are right. Direct jump can happen from a susceptible, can acquire HIV directly without an intermediate step of STI.
And sir,
Yes,
as
please.
जैसा हमने आपने पिछले बताया COVID-19 के जो steps बताया आपने,
हाँ.
whenever one patient recovered, then he can't be died. So this imply कि यहाँ पे भी jump हो जाएगी ना first से सीधा 5th step पर.
Oh, पीछे the project slide वाला.
लास्ट स्लाइड आपने बताया कि कोविड-19 का डेटा इकट्ठा करने के लिए स्टेप.
हाँ, ये स्टेप.
इफ पेशेंट्स आर रिकवर्ड देन कांट डाई ना.
करेक्ट. यहाँ जो ये हर स्टेप स्टेट नहीं है, ये स्टेप है, स्टेप ऑफ कलेक्टिंग द डेटा. इसका स्टेट स्पेस आप बनाओ. पर्पस ये प्रोजेक्ट है, स्टेट स्पेस आप बनाओ, उसमें स्टेट्स क्या है आप डिसाइड करो. उसका जो ट्रांजिशन प्रोबेबिलिटी है, ट्रांजिशन प्रोबेबिलिटी आप बनाओ, ट्रांजिशन मैट्रिक्स बनाओ, मार्कोव चेन बनाओ, एवरीथिंग आप सब बनाओ. उसका में क्या क्या स्टेट है. फॉर एग्जांपल स्टेट्स अगर देखोगे तो पेशेंट्स विथ कोविड बट नो कोमॉर्बिड कंडीशन एक स्टेट है. पेशेंट्स विथ जो नोटेशन लगाओ 0 या 0 1 1 2 3 4 5 एंड पेशेंट विथ कोविड विथ कोमॉर्बिड कंडीशन दूसरा स्टेट है. एंड patients with no comorbid condition recovered, another state. Patient with comorbid condition recovered, another state. Patient with not having comorbid died, another state. Patient may not recover, they die in the hospital. So अलग state है. And then patient with comorbid died. So 1 2 3 4 5. So various states you can include in the data, include in your chart, and then how the transition is happening.
Okay.
Okay. This that way you can think, and one can notation of our choice 1 2 3 4 5 or 0 1 2 3 4 5 1 2 3 4 or any A B C D or whatever our choice. I J K L M. That's a good question. So now the probability of transition from the graph we again construct a transition matrix. That means this is 0 to 0 probability of remaining in the say. That means a driver or a person is not getting any discount means what? Some accident occurred. That's why they remain in the same, no discount zone. This remains there. It remains 0 to 0. One probability of remaining in the same state is 1 by 4. And probability 0 to 1 transition 25% discount wala state mein jaane ke liye probability 3 by 4. And the driver who has accident will come back to 0, one state down, and the driver who in state 2 come down to lower state. So so the first step is once these data 0 1 2 आप COVID के लिए बना, उसके बाद the transition probability, then you make this chart, this transition matrix.
Okay.
Now you see this is stochastic matrix also. 1 by 4 plus 3 by 4 is 1. 1 by 4 plus 3 by 4 1. 0, 1 by 4 plus 3 by 4 is 1. So this is stochastic matrix. And 1 to 1 is 0. So a person with, in a year, suppose second person is in the state 1. That means currently availing 25% discount. उनका जो premium है 25% discount मिल गया. And when the driver is getting a 25% discount in the same year, suppose no accident. No accident in that year. That means where the person will go? Person goes to the 25% discount. After that is 50%. They'll go move here. If there is an accident during this year, person will come down here. So there is no chance to stay there. That's why P11 is 0. Probability to remain in the same state when the state 1 is 0. Whereas state 2...
Excuse me.
Yes, please.
Sir, as far as the stochastic model is concerned, for studying any kind of problem, is it necessary that the matrix should be stochastic?
That's a very good question. Fantastic question. And yes, this has to be, if this, that means incompleteness is there. When the transitions are not, that means that some of the patients have moved out of the, you cannot compute them. So uncertainty is added there. Uncertainty means uncertain in the transitions. This is a very good question. So I thought of covering that later, but since you asked that, yes, if it is a stochastic matrix, then the transition P square, P cube, all that we computed yesterday, that will be, they are all valid. They remain as a stochastic. Suppose in this case, some of the patients you collected the data, as previous question I asked in the hospital. बीच में hospital से कहीं patient निकल गए, you have no information. Patient discharged themselves without informing hospital, or some other reason you could not track, or files loss हो गया, कुछ हो गया, you have no information. So you don't know the transitions happened or not. And we cannot say not happened, we can say happened. So we cannot compute, we have to leave it blank. We cannot include some wrong data and then some, that becomes a error in the data cleaning aspect. So that way we have to...
It will always be stochastic if the model is correct, if the modeling is correct.
No, the data part.
Okay, data is correct, then the sum of rows, either rows or columns will be 1. Definitely.
Total, exactly, because the law of probability बोलता है कि आपको हर patient कुछ ना कुछ होगा. In this case, for example, you recruit say 500 drivers. 500 drivers का recruit करो, and then everybody will be in the stage 0 in the first year. उसके बाद इसमें से कितना लोगों out of 500 say 350 move to second stage 2, stage 0 to 1. उसका मतलब है 150 drivers remained here. They had some accident.
Right, sir. Got it.
But, yeah. So now for this kind of problem, probability, we can compute. You can see that probability of holding maximum discount in the year 2 is 9 by 16. 3 by 4 multiplied by 3 by 4. That is P square in the previous slide. So remain 2 years, 1 year remained, another year. So 3 by 4 into 3 by 4, that 9 by 6 for 2 years.
Sir,
plus 2. Yeah, go ahead.
Sir, in the previous slide, what about the sum of the values in the column 2? Even though the sum of the values in all the rows is equal to 1, but what about the sum of the values in the column 2?
In this case, it is not 1, but still fine. Stochastic matrix means either column sum is 1 or row sum is 1.
Right, sir. Okay, sir.
Yeah. So after 2 year discount, the probability of holding, now you say is matrix or what else we can nikal sakte hain, then you see that the 2 year, first year 3 by 4 probability to remain there, and the second year also remaining there, and so 3 by 4 multiplied by 3 by 4 is 9 by 16. So probability that given a driver who is already in the 50% discount, what is the chance that the driver will be there for 2 more years? 2 years is, that is n to n plus 2, 2 years, that is 9 by 16. Like that kind of probability, so one can compute, which is not possible through a mathematical model. Since we just now we heard mathematical model, this kind of answers cannot be provided by further. And then these are all needed for insurance companies. These kind of things are needed. What is it? Because insurance company premium, आपको कैसा बनता है insurance? Any suppose you want any company, I don't want to name any company. The motor companies or insurance, how do they make money? They make money from the premiums we all pay. We all pay the premiums, and then from the premiums they collect the money, and that money is distributed for the for the persons who got in any accident in that year. And you know the number of accidents are always less than number of drivers in a year. Accidents ज़्यादा हो सकता है, लेकिन the total number of premiums paid is much higher, many more people, many times more than the number of accidents. So number of accidents, the money they give it for the car repair or anything is from the money we pay as the premium. So at the time of beginning, similarly the health insurance or other things, at the time of the premium is decided how long the driver would not be having any accident and how long they will have accident. If all the drivers make accident, suppose in a premium company, in an insurance company, 1 million or 10 lakh people buy insurance from one company, and all the 10 lakh individuals make accident in that year. So, insurance company is in a loss, will be in a loss. But only out of 10 lakh individuals paid a premium, only 1% of that make an accident. That means the company is in a big profit. Is our premium payers money. So these all requires what is the chance of the chance factors play a big role. That means probabilities. So this kind of models, insurance probability, stochastic models plays a bigger role. And then next we see the n-step transition probabilities. So in general, these all are already by this time all the participants would have understood 2-step, 3-step, similarly n-step. So if A is an event, X and B a random variable, so new notation here, P of A stands for probability A, an event from the beginning, the same as the previous notation. So first event, probability Pi, you see here I. PIA is a new notation I've introduced. PIA means you start from I and reaching A. Previously it was IJ, now it is I to A. PIJ, see here I to J. I से शुरू हुआ, PI जब suffix लिखा उसका मतलब है it is x0 is equal to I. Initial state is. So this is also various notations in various books. So just make sure that you know various things we understand. Now, initial distribution of the, which we treat here as a row vector. Sorry. Oops. Yeah. That means here, let me come back here. So Pij means started from I, initially at I state I, and moving to state J. Initially at state I and moving to state J. And then let theta be the initial distribution. The initial distribution means in the population when there are a lot of individuals are there in a large sample, then the initial what distribution of the states, that is known as initial distribution, which is nothing but the row vector. Row vector with all the values you see here. Theta 1, theta 2, theta 3, they could be initially in the first state, second state, and so on. So probability, now see there is no suffix, x1 equal to j. Then notation again, we just follow the notation. Probability x1 equal to j means it could start from any other state. There is no suffix here, you see. No suffix here means they could be from any state one can start and then reaching j, from any state to j. That's why theta I from I belongs to the state space, this notation. I belongs to S means S is a state space. Theta I, this I changing. So kahin se bhi shuru hua and reach it J. So Pi from starting from theta I, initial distribution, initially at theta I, then I to J. So this is written as theta I Pij. So this is how for n-step transition, that means generalized situations. Generalized situations, just for understanding sake, because of practical purposes, you know, we don't have in general n-step. N-step means if you replace n by 10, 10 step, n by 5, 5 step. So 5 steps means yesterday, aapko yaad hoga, you know, you all remember that. In that, even for our situation also, so, you know, this, what is that example here? This example. So first step, 2 to 2. Second step, again, second year remain there, third year remaining there, fourth year remaining there, fifth year remaining there. So each year you are there. That's a 5-step. We completed yesterday. So if you check yourself as a homework, as a no credit homework, p square, p cube, p power 4, all this you compute, p square, and then you see how the values are, these values changing. P power 5 means that these values are 5-step probabilities. So how to theoretically measure that? This is the purpose of that. Similarly, x2j, x1 को हम लोग अभी सुना, x2j means initially start from I to k, that means I to k, k to j. So that is p I to k, k to j. Then p square j, that is theta p square. Just a notation. I'm telling you why I showed was even after the coursework, you may encounter any book. So nothing to get worried. Just because this is, about 12 lectures, usually the entire stochastic process is about 60 lectures course I give if I teach for one semester. 60-hour lectures on stochastic process. But then you all very active this thing. We advanced a lot. So just for the sake of you to nothing to get worried about n-step transitions, I just showed notation wise. This is how we denote. Theta I comma k, theta I pik, pkj means this is like n-step transitions. For my various sets are there. We don't know what are there, but I comma j comma k are arbitrary states in S. They are not just 3. There are many more. There are finite number of states. This is how we denote. So notation also important, as I mentioned. Just work out what's happening. P of x1 equal to j summation theta I pi x1 equal to j and so on. Similarly, theta 2 probability x2 equal to j means, see, there is no suffix. That means it could start from anywhere. Anywhere means theta I, just arbitrarily I. Initial distribution from I to k, k to j, x1, first step, I to k. K could be anything, any state out of S, any state out of S. And k to j, j could be any state out of S. But I, j, k are not same. I not equal to j, j not equal to k. Similarly here, now when you start from I, we don't need initial distribution because already initial distribution is given. We don't need theta I. See here, that's the notation. When there is no theta I means initial distribution is already given I. When we don't know where to start, you start from I. So you don't need to multiply that by I. And so again, the review, just to make sure that you understand the review of probability. The slides also shared with you all. Make sure that you work out after the lecture because this is a very intensive course going on for all of you and evening times. Understand, but after the lecture, make sure that you go through the slides from the beginning again thoroughly. Everything is explained to you. You relate to that, or you look at the YouTube this, and then you please look at the yes, बोलिए. अच्छा, आपका वॉइस शेक हो रहा है नेटवर्क की वजह से. I can't audible. Dr. Ridu, you want to translate to me? If you can hear.
Yes, sir.
Yeah, I could not hear the question because of network connection.
Actually, your internet connection is poor. Participant? Yes, sir. Sound is not clear.
And Dr. Redu can ask.
You can write in the chat box. Yes, ma'am.
So this is an important slide. आप सब notation को ध्यान दीजिए इधर क्या हो रहा है. So this is how, because when you have to build your own math models or stochastic models, you have to write the equations in the paper, article, and आपको publish करना होगा. You have to, theory is important and you have to apply it. So this is about taking the theory to the how close we can take it to the reality. This is about that. This course is about that. So we need to know the theory also very well. So probability x2 equal to j, all these things, and then there means nothing, no initial distribution given. So you start from arbitrarily I to theta I, pi, I to k, k to j, the theta I, pi k, pk j. When the initial distribution is given, then you don't need it. So that's a pi k, pk j. So if we keep on continuing, so that's why the idea is here. If you formulate a transition matrix, Pn, that is same as, thus, xn equal to j, xn equal to j means nth step, it is value j, starting from nowhere is equal to theta Pn, and if you start from I to j, is p power n. That means p to the power within the bracket n equal to paj n. I to j, that's what is the nth step transition. As I mentioned, this is just for the sake of abstractness I explained, but you all understood. If it is for the 5-step or 10-step, what is the meaning of that already understood, just for the sake of introduction. As I mentioned, gambler's ruin model. Gambler's ruin model, there is a classic name, ruin, because gamblers never, an arbitrarily picked gambler or arbitrarily picked gambler is never happy. You pick up any gambler, if you know anyone, never you see that a gambler is happily every day he goes to game and they come back. No, most of the gamblers are ruinous. Their families are suffering. So that's why gamblers ruin model. That's the name given classically, all the books you see historically 50, 60, 70-year-old books also. Gamblers ruin model. Gamblers usually ruin their money. So gambler goes to a play area, play center, and then each time a gambler wins a game, $1, and then gambler is lost, $1 is lost. So total possible amount gambler can win is $n, suppose say, and then that means that's maximum money the gambler can win. And gambler leaves the game center as soon as gambler has either $n or $0 in terms of rupees. So maybe you can write it. I don't have symbol in my keyboard. That's why I took type the dollar. The rupee symbol is not there in my keyboard. Okay. So gamblers do, that means gambler goes to a gambling center with some pocket some money, and then each time he play a game, gambler won the 1 rupee, and that particular game is lost, 1 rupee is lost. So if that gambler become gambler, finally will have 0 rupees, he will come back, quit the gaming center, come back, or a certain amount reached a capital N rupees, gambler come back, leave the center. So each time the jump is only $1 or 1 rupee. So you see that each time initial amount x0, suppose dollar goes in the gambler goes with 5 rupees in the pocket, and each time 1 rupee, each time win a game, 1 rupee, 6 rupees, or lose 4 rupees. So x1 with I+1, gambler wins the first game. X1 equal to I-1, gambler loses the first game. So x0 is the starting value amount, and x1 is not predictable, isn't it? That's why it is a stochastic model, because x0 to x1, the transition is not predicted. The value, whether I+1 or I-1, is not predicted in advance. That's why it's a stochastic model, not a mathematical model. So these kind of subtle things, now you understood. So the state space is 0 to n. Then 0 also, that the gambler loses all the money, 0 rupees, 1 rupee, 2 rupee, and so on. Initial amount, you see x0 is the amount gambler possesses at the beginning. Beginning, it could be any, I could be obviously not 0, because you cannot play the game. Obviously not n, because you cannot n, because n rupees, that means gambler is have to leave the center. So in between 1 to n-1. So the amount of rupees at time n is depending on the amount of rupees at time n minus 1. So this is an example, Gambler's ruin model, also a kind of example for a random walk model. And this holds Markov property. Now classification of states. So just a minute. Yeah, so I would start this in the next lecture of mine. Classification of states. This is important aspect. So let me. This thing I will start this in the next lecture. Any questions so far in today? If you like, or if you're okay with the speed of the lectures, if I'm going fast or slow, feel free to. Next we will also again a bunch of theory coming up on the how do we classify various kinds of classification can be done for the stochastic models. First thing is classification of the model. So next thing you saw the slide, classification of the state, not the model. Classification of the model already you saw, continuous time, discrete state, discrete space, discrete time, and continuous time, all these things, continuous and discrete, both the type of models, and continuous state and continuous time. All kind of 4 models you saw. Now next coming up is classification of the state. How do we classify a given state? This is very important. With that we are coming to the important phase of the course. But today's lecture would end here. And feel free to tell me the speed of the course, or you want to go more slower than or more fast, or you're okay with that. Are any questions? Welcome on the today's part.
Sir.
Yes. Please.
Can I ask?
Yes, please ask.
Sir, in yesterday's lecture, आपने सर जो पेपर दिखाया था डीप लर्निंग विद मार्कोव मॉडल ऑन इनवर्टेड ह्यूमन, sir, can you please share the data with me? Actually,
yeah, please. I'll be happy to share today's lecture. Whatever in the HIV, I just sent to Professor Kumar, and similarly yesterday, I thought I sent. I think I didn't send. I forgot. I will send it.
Oh, okay, sir.
If you cannot download, I can. Send.
Okay, sir. And sir, one more thing. Sir, in a maternal health risk prediction problem, we are given the risk factors associated with pregnant women, like low risk, high risk, and mid risk. So, can we consider it as a state space? Like low risk 0, 1, and 2, can we take it as a state space?
0, 1, and 2. If the transitions are happening between the risk to low risk to high risk, the risk is changing. Yes, you can consider that as a state. But if you are not interested in the transition between high risk and low risk, and the doctors are not interested in that cannot be. I mean, there no need of making them as a state.
Okay. And sir, if we are not given any probabilities related to transition from low to mid and mid to high, and we are predicting the risk, ultimate goal is to predict risk, then do we need to apply the concept of Markov chains and a state space?
Ultimate risk of what? Risk of getting pregnancy or risk of not getting pregnancy?
Risk associated with pregnancy during delivery. Like the pregnant woman will be having a high risk of delivery, high risk complications.
Okay, that means high risk means here the premature baby or normal baby. That's what you asked me.
Yes, sir. Yes, sir. Baby delivery.
Baby delivery.